You know what keeps astronomers awake at night? It isn't the thought of asteroids smashing into Earth or the sun suddenly going dark. No, what really terrifies them is something far more sinister, something invisible that travels at the speed of light and could wipe out half the planet before we even knew it was coming. We're talking about gamma-ray bursts, the most powerful explosions in the universe since the Big Bang itself. And here's the kicker. One could be pointed right at us this very second, and we'd have absolutely no way of knowing until it was too late. So what exactly is a gamma-ray burst? Well, think of it as the universe's ultimate sniper rifle. When certain massive stars die or when neutron stars collide, they release an incomprehensible amount of energy in the form of focused beams of radiation. These aren't your everyday explosions that radiate energy in all directions. These bursts shoot out in narrow jets, like cosmic laser beams, and if Earth happens to be in the crosshairs, well, that's when things get really interesting. The thing that makes gamma-ray bursts so particularly frightening is their speed. They move at the speed of light, which means there's no warning system, no early detection, no time to prepare. One moment everything is fine. The next moment our atmosphere is being bombarded with radiation so intense it could strip away the ozone layer in seconds. And without that protective shield, all life on the surface would be exposed to lethal doses of ultraviolet radiation from our own sun. The oceans would be affected, the food chain would collapse, and humanity would face an extinction-level event that makes nuclear war look like a mild inconvenience. Now, you might be thinking, surely this is just theoretical scaremongering, right? Scientists love to come up with doomsday scenarios that never actually happen. But here's where it gets chilling. We know for a fact that gamma-ray bursts have already happened throughout cosmic history. We detect them regularly, sometimes multiple times a week, going off in distant galaxies billions of light years away. Every single one of these events releases more energy in 10 seconds than our sun will produce in its entire 10 billion year lifetime. Let that sink in for a moment. 10 seconds versus 10 billion years. That's the scale we're dealing with. Back in 1998, astronomers detected a gamma-ray burst designated GRB 971,214. When they calculated its distance and energy output, they were stunned. This single explosion was so bright that if you could see gamma rays with your naked eye, it would have outshone every star in the night sky combined, despite being 12 billion light years away. 12 billion light years, and it was still the brightest thing in the gamma-ray sky for those few precious seconds. What would happen if something like that went off in our own galaxy, say, just a few thousand light years away instead of billions? Scientists have run the simulations, and the results aren't pretty. If a gamma-ray burst occurred within 6,000 light years of Earth and was pointed directly at us, the initial blast would hit our atmosphere with the force of multiple nuclear bombs going off simultaneously across the entire planet. The gamma rays would interact with nitrogen and oxygen molecules in our upper atmosphere, creating nitrogen dioxide, the brown hazy pollutant you see over cities. Except this wouldn't be a local smog problem. The entire planet would be engulfed in a thick brown haze that would block out sunlight and trigger a catastrophic cooling event. Basically, instant nuclear winter without the nuclear war. But that's just the beginning of our problems. The nitrogen dioxide would also react with water vapor to create acid rain, and we're not talking about the mild stuff that damages forests over decades. This would be concentrated nitric acid falling from the sky, poisoning water supplies, destroying crops, and making large areas of the planet completely uninhabitable. Marine life would be devastated as the oceans absorbed this acid, killing off plankton, the foundation of the ocean food web, and incidentally one of our planet's primary oxygen producers. You see how quickly this domino effect spirals out of control. The truly unsettling part is that some scientists believe this has already happened to Earth. There's a mass extinction event that occurred about 450 million years ago called the Ordovician extinction. During this event, roughly 85% of all marine species were wiped out. For decades, scientists couldn't figure out what caused it. The timeline didn't match up with any known asteroid impacts or volcanic eruptions. But then someone proposed an idea that sent shivers through the scientific community. What if Earth was hit by a gamma ray burst? The evidence is circumstantial, but compelling. The Ordovician extinction happened in two distinct pulses separated by about 1 million years. The first pulse coincided with a sudden global cooling, and the second with the destruction of the ozone layer, exactly what you'd expect from a gamma ray burst. Species that lived in shallow water were decimated, while deep-water species survived at higher rates, which makes sense if deadly ultraviolet radiation was pouring down from above. The geographic pattern of extinction also suggests that one hemisphere of the planet was affected more severely than the other, consistent with a directional blast from space. Now, before everyone starts building underground bunkers, there's something important to understand about probability. The universe is incredibly vast, and Earth is a very small target. For a gamma ray burst to hit us, first, it needs to occur relatively close by in cosmic terms, and second, it needs to be aimed precisely in our direction. Those narrow jets we talked about, they're only a few degrees wide. It's like trying to hit a pinhead with a laser pointer from across a football stadium while blindfolded. The odds are astronomically small, which is probably why life on Earth has survived for billions of years, despite these cosmic threats. But small odds aren't zero odds. Astronomers have identified several stars in our galaxy that could potentially produce gamma ray bursts when they die. One of the most famous candidates is a star called WR104, located about 8,000 light-years away in the constellation Sagittarius. This isn't just any star. It's a Wolf-Rayet star, a massive beast that's already in its death throes, burning through the last of its nuclear fuel. Wolf-Rayet stars are known to be the progenitors of gamma-ray bursts, and here's the really concerning part. Some observations suggest that WR104's rotational axis might be pointed more or less toward Earth. When news of this first came out, it caused quite a stir in astronomical circles and among space enthusiasts. Was humanity living under a cosmic sword of Damocles? Could WR104 explode tomorrow and end civilization as we know it? Well, the good news is that more recent and detailed observations suggest the star's axis is tilted at least 30 degrees away from Earth, which means we're probably safe. Probably. The uncertainty comes from the difficulty of measuring these alignments across thousands of light years. It's not like we can fly a spacecraft over there and check with a protractor. Even if WR104 isn't pointed at us, there are other candidates. Eta Carinii, one of the most massive and unstable stars in our galaxy, sits about 7,500 light-years away. This monster has already shown signs of instability, having undergone a massive eruption in the 1800s that briefly made it the second brightest star in the night sky. When Eta Carinii finally explodes, and it will, it could be spectacular. Some astronomers believe it might also be oriented in a way that could pose a risk to Earth. Though again, the uncertainties are large, and most estimates suggest we're outside the danger zone. There's another type of gamma-ray burst that's even more unpredictable, and that's the kind produced by colliding neutron stars. Neutron stars are the collapsed cores of dead massive stars, objects so dense that a teaspoon of their material would weigh as much as Mount Everest. When two of these cosmic monsters spiral into each other, they create a cataclysmic explosion that releases enormous amounts of energy, including gamma-ray bursts. The problem with these events is that they're almost impossible to predict. We don't have a complete census of all the neutron star binary systems in our galaxy, and some of them could be merging right now without us knowing about it. In 2017, astronomers made a groundbreaking detection. For the first time, they observed both gravitational waves and electromagnetic radiation from a neutron star merger. This event, designated GW 170817, occurred in a galaxy about 130 million light-years away. The gamma-ray burst that accompanied it was relatively weak by cosmic standards, but scientists realized something important. If that same event had occurred just a few thousand light-years away and pointed at Earth, it would have been catastrophic. The detection of this event opened up an entirely new way of studying the universe, but it also reminded us that these existential threats are real and ongoing. So what can we actually do about this? Is there any defense against a gamma-ray burst? The short answer is no. There's no shield we could build, no place we could hide that would protect the entire planet from such an event. Unlike asteroids, which we might be able to deflect with enough warning, or even solar storms, which our magnetosphere helps protect us from, a gamma-ray burst would bypass all our natural defenses. The only real protection would be distance and angle, factors completely beyond our control. That said, scientists aren't sitting idle. Monitoring programs constantly scan the sky for gamma-ray bursts, partly to study these fascinating phenomena and partly to assess potential threats. Satellites like NASA's Swift Observatory and the Fermi Gamma-Ray Space Telescope detect dozens of gamma-ray bursts every year. Each detection adds to our understanding of where they come from, how they form, and most importantly, how common they are in different types of galaxies. The more we learn, the better we can assess the actual risk to Earth. One thing researchers have discovered is that gamma-ray bursts seem to be more common in galaxies with low metallicity. Metallicity, in astronomical terms, refers to the abundance of elements heavier than hydrogen and helium. Our Milky Way galaxy has relatively high metallicity compared to many galaxies in the universe, which might mean that gamma-ray burst-producing stars are somewhat rarer here. That's potentially good news for us, though it's not a guarantee of safety. There's also the time factor to consider. Massive stars that produce gamma-ray bursts have very short lifetimes by cosmic standards, typically just a few million years. The stars currently in our neighborhood capable of producing gamma-ray bursts have probably been stable for a while and might continue to be stable for thousands or millions of years more. But again, cosmic timescales are tricky. A million years is a blink of an eye in astronomical terms, but it's an eternity from a human perspective. What makes this threat particularly insidious is its invisibility. We can see asteroids coming, we can predict solar storms, we can monitor volcanic activity and seismic patterns. But a gamma-ray burst. The first sign would be the burst itself slamming into our atmosphere at the speed of light. There will be no time to react, no evacuation procedures, no emergency broadcasts. One moment you'd be going about your day, and the next moment the sky would be filled with auroras as the upper atmosphere was ionized by incoming radiation. Scientists on the ground might have a few seconds to realize what was happening before communications systems were fried by the electromagnetic pulse. After the initial blast, assuming anyone survived, the long-term consequences would be equally grim. The destruction of the ozone layer would persist for years, possibly decades. Survivors would need to remain underground or heavily shielded from solar ultraviolet radiation. Agriculture would be virtually impossible on the surface. The global temperature drop from the atmospheric haze would trigger widespread famine. Even if some hardy humans managed to survive in protected environments, rebuilding civilization would be an almost insurmountable challenge. Yet despite all this doom and gloom, there's a strange comfort in the numbers. The Milky Way galaxy is about 100,000 light-years across and contains somewhere between 100 and 400 billion stars. Earth is positioned in a fairly quiet suburban region of the galaxy, far from the chaotic and radiation-drenched galactic center. The nearest stars capable of producing gamma-ray bursts are thousands of light years away. When you run the probability calculations, the chance of a civilization-ending gamma-ray burst hitting Earth in any given year is vanishingly small, somewhere on the order of 1 in several million at most. But here's something to ponder. The universe is nearly 14 billion years old, and Earth has been around for about 4.5 billion years. Life has existed on our planet for roughly 3.5 billion years. During that enormous span of time, Earth has been hit by asteroids, bombarded by solar storms, subjected to supervolcano eruptions, and experienced several mass extinctions. Yet life persisted. Even if the Ordovician extinction was caused by a gamma-ray burst, life recovered. It always has. That's both humbling and oddly reassuring. The question isn't really whether gamma-ray bursts exist or whether they're dangerous. We know they do and they are. The question is whether we, as a species, should spend our time worrying about threats we can neither predict nor prevent. Some argue that effort and resources would be better spent on addressing immediate challenges like climate change, nuclear proliferation, or pandemic preparedness. Others counter that understanding cosmic threats helps put our existence in perspective and motivates us to become a multi-planet species. If humanity only exists on Earth, then a single catastrophic event, whether from space or from our own actions, could end us. But if we spread across the solar system and eventually to other stars, our chances of long-term survival increase dramatically. This brings us to an interesting philosophical point. Gamma-ray bursts remind us of our cosmic vulnerability, but they also highlight our unique position in the universe. We're the only species we know of that can even comprehend these threats. No other creature on Earth lies awake at night, contemplating the possibility of stellar explosions wiping out civilization. Only humans have the capability to detect these events, study them, understand their mechanisms, and at least theoretically plan for long-term survival strategies. That ability, that awareness, is what makes us remarkable. There's something profound about knowing that the light from distant gamma-ray bursts has been traveling through space for billions of years, crossing incomprehensible distances, only to arrive at Earth, where a handful of instruments detect it, and a small group of scientists analyze what it means. Each burst is like a message from the deep past, a snapshot of a violent cosmic death that occurred when our planet was young or perhaps before Earth even existed. These ancient explosions shaped the universe, forging heavy elements in their incredible heat and pressure, elements that eventually found their way into new stars, planets, and yes, into our own bodies. The iron in your blood, the calcium in your bones, the oxygen you're breathing right now, all of it was created in stellar furnaces and scattered across the cosmos by supernova explosions. In a very real sense, you are made of stardust, forged in the hearts of dying stars. Some of those stars might have produced gamma-ray bursts. The universe is violent and dangerous, but it's also creative and beautiful. The same processes that could destroy us also made us possible. So where does this leave us? Should we be afraid? Should we build deep underground shelters and prepare for the worst? Probably not. The likelihood of a gamma-ray burst hitting Earth during our lifetimes, or even during the lifetime of our species, is incredibly remote. But should we be aware? Should we continue studying these phenomena and working to understand our place in a vast and sometimes hostile universe? Absolutely. Knowledge isn't just power, it's perspective. Understanding gamma-ray bursts doesn't just teach us about cosmic dangers. It teaches us about the universe's grand cycles of death and birth, destruction and creation. Every night when you look up at the stars, you're seeing ancient light from distant suns. Some of those stars no longer exist. They exploded millions or billions of years ago, but their light is only just reaching us now. Somewhere out there, right now, a massive star might be in its final moments, preparing to unleash a gamma-ray burst that will tear through space for thousands or millions of years before reaching some distant world. Maybe that world is empty. Maybe it harbors life. Maybe that life will be looking up at their own sky, wondering about the same cosmic mysteries that captivate us. The universe doesn't care about our fears or our hopes. It operates on scales of time and distance that dwarf human comprehension. Gamma-ray bursts will continue to occur whether we worry about them or not. Stars will live and die, galaxies will collide, and the cosmic dance will go on. Our role in all of this is simply to observe, to learn, to understand as much as we can in the brief time we have. And maybe, just maybe, to appreciate the incredible improbability of our existence. Against all odds, on a small rocky planet orbiting an average star in an unremarkable galaxy, life arose and eventually became conscious enough to ask questions about gamma-ray bursts. That's the real story here. Not the danger, not the fear, but the wonder. We live in a universe capable of producing the most violent explosions imaginable, yet here we are, alive and aware, asking questions and seeking answers. The gamma-ray burst that could kill us without warning probably won't. The odds are in our favor, not because the universe is kind, but because the universe is vast and we are small. And in that smallness, in that vulnerability, there's a strange kind of comfort. We're all in this together, spinning through space on our little blue marble, temporary visitors to an ancient cosmos that will outlive us all.